Okay, so in this lecture, we are going to do a little warm-up. So how can you think of this lecture? This is just like warming up when you do exercise. The goal is to get you primed for specific movements and for the specific ways of thinking that we will use in this course. It should also give you some sense of the kinds of tools that we will use in this course and the level of complexity you should expect. Note that if you've taken courses with me before, you can comfortably skip this lecture. Okay, so let's begin. So your first exercise is to use NumPy to generate 1,000 random samples from the standard normal. That is, samples from the normal distribution with mean 0 and variance 1. Note that this lecture will also help us to introduce some notation. You'll see that I'm using this unconventional letter n to mean the normal. This is so that we don't get it confused with the regular n, which I usually use to mean the number of samples in a dataset. Okay, so once you've generated these samples, you'll want to plot the samples as a time series. The next step is to plot the samples as a histogram. Alright, so for the next exercise, you're going to add a trend line to the noise that you just generated. Once you've done so, it should look something like this. Note that this is a scatter plot, not a line chart. I'll let you pick the parameters of the trend line, so play around with different values until you get something that looks reasonable. As a bonus exercise, you can try finding and plotting the line of best fit to this data, although we'll be going through that in this course anyway. The next exercise is to call the CumSum function on your noise, which calculates the cumulative sum of the array that you pass in. Next, I want you to take that output and plot it as a time series. Consider what kind of time series this reminds you of. In the context of this course, the answer should be pretty obvious, but think about how what you just did might be related to what we will learn in the coming sections. In the next exercise, I want you to generate 1,000 samples from the multivariate normal. This will have the mean vector 0, 0, and the covariance matrix 1 minus 0.5 minus 0.5 and 2. You can also use SciPy for this, or any other library you prefer. Once you have your samples, I want you to plot them using a scatterplot. Again, this might not seem like much right now, but keep these concepts in mind as you go through the course. Your next exercise is to take the samples you just generated from the multivariate normal and calculate the sample mean and sample covariance from your data. Consider whether or not these estimates are close to the values you expect. As a bonus, do not use the mean and cov functions in NumPy, but instead use the actual formulas. This will be useful for understanding many of the concepts in this course. Alright, so I hope this little warm-up has been pretty easy. By the way, you can see that this is not the kind of course where we're going to spend 2 hours learning basic Python, 2 hours learning pandas, and so on. As you can tell from these warm-up exercises, this knowledge is knowledge you should already have. It's my general feeling that, if you just learn basic spelling and grammar today, you won't be ready to read Shakespeare tomorrow. And that's what it would be like if you just learned basic Python and then tried to do financial engineering. Hopefully you agree with me that this is rational. So please take your time and remember that you have this course for a lifetime. There truly is no rush. And please note that I do teach NumPy, Pandas, SciPy, Matplotlib, and scikit-learn for free. Therefore, there is absolutely no excuse for not meeting these prerequisites. It's easy, it's free, and most importantly, it's only beneficial to learn them. In other words, it helps you. So help yourself and give yourself the best possible start that you can by taking advantage of this free content.